we have treated certain things about RLC circuits, and it's time for us to understand certain other things that has to do with RLC circuits. And today we are going to learn phasor or vector AC diagrams. So look at it very well. The board is filled with certain facts about an RLC circuit. We have learned the basic concepts of what RLC circuit is all about, when a resistor is connected, when a capacitor is connected, and when an inductor is connected, respectively. What happens? We have learned all that in my previous videos. So today we are going to see the analysis involved in analyzing each of these components. So the first thing we need to understand is this: when an AC voltage is supplied to an RLC circuit, what happens? The current has the same frequency with the voltage. Frequency of the current and voltage is the same, but the two quantities are out of phase. That's meaning frequency is the same, but the two quantities, current and voltage, are out of phase. That's the problem here. So if they're out of phase, what does that mean? If they're in phase, what does that mean? We're going to take this one at a time. So let's begin with phase. What phase is all about? Phase simply refers to the state of vibration of a periodically changing system at a given time. At a given time. And that's where we have omega t. That's the angular, some sort of angular difference, okay? Or we have it as phase difference or phase angle. That's what we have there. Because these changes occur periodically when there is current and voltage alternating. Periodically. That's what it means. If we have understood this, then we need to understand when these two quantities, current and voltage, are in phase, and when these two quantities, current and voltage, are out of phase. So let's look at when they are in phase. Current and voltage are in phase when their maximum, zero, and minimum occur at the same time. If they occur at the same time, the two quantities are said to be in phase. That's the meaning of this. If we have understood this, we need to also understand when they are out of phase. I repeat, we need to understand when they are out of phase. So let's look at it. Also, on the other hand, if these two quantities, current and voltage, their maximum, zero, and minimum do not occur at the same time, they are said to be out of phase. The two quantities are said to be out of phase. That's what it means. And if that happens, they cancel out. One leads and the other one lags. Oh my goodness. This is interesting. If they are out of phase, under this condition, one must lead. One must also lag. So they cannot move in the same phase because they are out of phase. But if they're in phase, they move in the same step. Alright? Stepwisely. That's what happens. Now let's take it up once again. Of course, we know that in an RLC circuit, is always a varying voltage that is supplied. And that varying voltage is represented by this value, V equals to V naught sine omega t, when it involves what? RLC circuits. Now, if we have a varying voltage or an alternating voltage, of course, an alternating voltage will produce an alternating current. And that's what happens here. And since this involves RLC circuits, current lags behind, voltage lead. That's what happens. And because current lags behind, okay, it has to do with minus by that factor through which it lags. Okay? That factor, it lags. That is the pi over 2 or 90 degrees, pi over 2 radians or 90 degrees. That's the factor here. But this factor is represented by phi, Greek letter phi, which is always used in scientific representation most times. Now, this phi is referred to as phase difference. That's the difference between the leading of the voltage and the lagging behind of the current. This phase difference, how much angle does it have? That's what it means. And for us to be able to calculate this, we must understand how to apply this. Phase difference is equal to tan inverse all over x over r, close again. So what does x represent? X represents the reactances. The reactances of a capacitive reactance and inductive reactance. The difference between the inductive reactance and the capacitive reactance. That's this. That's mean of x. And it's measured in ohms. The next one is R. Of course, it has to do with RLC circuits connected in series. Of course, the R they represent resistance being offered to that circuit by a resistor, and it's measured in ohms as well. Now we talk about the phi, which I have said something about briefly. It represents the difference in phase or phase difference. Is measured in radians. It's measured in radians. Now back to these points. Look at this. We have inductive voltage, capacitive voltage, and we have resistive voltage. If you look closely, you'll see that the inductive voltage and the resistive voltage seem to be in phase. But resistive voltage and capacitive voltage seem to lag each other. One is leading, the other one is lagging. The same thing applies here. And that's what we have. You can see the combination of inductive voltage and the capacitive voltage here, making a point here. And the resistive voltage is having an application along the horizontal axis. So with this, we have what we call vector AC diagrams. That's it. This is a vector AC diagram. This is another one. So resolving this, we use something like this. If we find the total opposition offered in an RLC circuit, we have the impedance. Okay? This impedance over the resistance offered in the circuit will help us to find the phase difference once again. This. That's what it means. And if we understand this, if we really understand this, we'll be able to solve any question coming from this angle. It won't be strange to us because we now know which one leads and then which one lags. In my next video, I am going to treat and we are going to learn what happens when a capacitor is connected and then the voltage being supplied, the behavior of the voltage being supplied against currents. We are going to learn that. The same thing we are going to learn when an inductor is connected and what happens even when a resistor is connected. So with this said, I will thank you for your patience at this point and then remind you to give thumbs up, put the bell button on for constant notification, share with your friends, networks, and students. Do not forget to always come back to this channel. Let people know about this channel. Promote it. Belong to this community of teachers, community of learners. You are welcome, my returning subscribers and my new subscribers. I give you thumbs up as well for belonging to this family. Thank you so much for your patience and thank you for finding value in this. I'm signing out. Come on. See you next time. Okay?